Good afternoon, children. Today we are going to discuss a new chapter, rational and irrational numbers. Rational and irrational number. Okay, we know many numbers, different types of numbers. That is, counting numbers is there, whole numbers is there, fractional numbers is there. Is it? Today, here we are going to discuss about a rational number which is always connected with the fractional numbers. What do you mean fraction? What is the meaning of a fraction number? A number which has a numerator and denominator means we can understand that is a fractional form. It is a fractional form. For example, 2 by 3 is a fraction. It's a fraction. 2 by 3 is a fraction. Here you see it's a numerator. This is denominator. That is 2 is numerator, 3 is denominator. Here the rational number is same as a fraction. One thing, this denominator never become 0. That is, it is not equal to 0. Then as same as numerator and denominator, it become an integers. It is integers. So the definition of a rational number is a number a by b where b not equal to 0 and a and b are integers. So you should write the definition. Now I will say the definition. You may write in your notebook. First write the heading rational and irrational number. After that write the definition rational number. A rational number is a number. A rational number is a number that can be expressed in the form a by b, in the form of a by b, comma, where a and b, a and small letters a and b are integers, and b not equal to 0. This is the definition of a rational number. Examples of rational numbers are 1 by 2, 3 by 4 or 5 by 7, anyone, etc. You can write any fraction that is a rational number. One thing, denominator not equal to 0. Next, we are going to discuss the properties of rational number. Some properties of rational number. The first property, a rational number is closed for addition, subtraction, multiplication and addition, which means we can do addition, multiplication, subtraction and division in the case of rational numbers. For example, 3 by 4 plus 5 by 7, we are going to add two rational numbers. That is, answer is 41 by 28. You know, take the LCM and add it. So we will get 41 by 28. Then similarly, subtraction, 3 by 4 minus 5 by 7, subtracting. That answer is 1 by 28. Then multiply together. Then become 15 by 28. Similarly, division, 3 by 4 divided by 5 by 7. So 3 by 4 into 7 by 5. Okay. Then 21 by 20. This is the first properties of rational number. Then second property, rational number is commutative. Rational number is commutative. You know what is the commutative property of numbers? Commutative property. Okay. Then if the order change in the case of addition and multiplication, if the order change, there is no change in the answer. There is no change in the result. That is the commutative property. Example, 1 by 5 plus 3 by 7. Okay. Then same as 3 by 7 plus 1 by 5. Okay, order change. Then answer is 22 by 35. Take LCM and solve it. Then similarly in the case of multiplication, 1 by 5 into 3 by 7. Then multiply 3 by 7 into 1 by 5. There is no change in the answer, but order change. That is the properties of commutative. That is second property. Third one is, next property is, rational number is satisfying associative property. Now, a rational number will satisfy the associative property. Then, what do you mean associative? If you are representing three numbers, you see, we can write it. It is the order. Then, first we are going to add that first two numbers, then third number. Similarly, here we are going to add the last two numbers and add the first number. The answer will be same. That is associative property. In your lower classes, you already learn. Okay. Then, in the case of multiplication also, 1 by 2 into 1 by 4 into 1 by 3 become, here you see, first we are open the bracket and multiplied with 1 by 3. Similarly, first here you may open the bracket, that is multiply together. Then after multiply with the 1 by 2, the answer will be same. That is associative property. Is associative property and commutative property satisfied in the case of subtraction and division? The case of subtraction and division, it's not satisfying in the case of subtraction and division, because if the order change, we can find the answer same. Okay, so it is satisfying in the condition of addition and multiplication. Okay. Then the next property is, a rational number exists, addition inverse or additive inverse and multiplicative inverse. What do you mean? Additive inverse. Additive inverse means when we add a number to a fraction, the result becomes 0. For example, here you see 5 by 8. We are going to add with the minus 5 by 8. This is the additive inverse of 5 by 8. That result become 0. Suppose 2 by 3 plus minus 2 by 3. When you are adding this together, it will become 0. Sure, take LCM and you know. Then suppose 5 by 9. So minus 5 by 9 plus 5 by 9. It will become 0. Here this positive 5 by 9 be the additive inverse of negative 5 by 9. That is the additive inverse. That is, when you are adding two rational number, the result become 0. That is additive inverse. But in the case of multiplicative inverse, when you are multiply two numbers, how we will multiply? Then example 1 by 2 into 2 by 1. Listen, 1 by 2 into reciprocal. Is it 2 by 1? That is, result is 1. That is, when you multiply a number and its reciprocal, the result become 1. That is also satisfying in the case of rational numbers. That is, generally a plus minus a is equal to 0, additive inverse. A into 1 by a, that is equal to 1, that is multiplicative inverse. It is general form. So, you may write all these properties in your notebook with the examples. Whatever I wrote on the board, you write in your notebook, clear it. Okay? Check these given numbers are rational or irrational. Okay, first one, 2 by 3. Usually you know 2 by 3 is a rational number. We already illustrated in our examples. Okay, 7 by 11. What about 7 by 11? It is also a rational number. Is it rational number? Then 5. What about 5? 5 is also a rational number because 5 we can written as 5 by 1. Is it? It is a numerator and denominator. Denominator is not equal to 0. So, 5 is also a rational number. Understood? It is also a rational number. Then, what about root 16? What about root 16? It is a perfect square root. See it, 4 4s are 16. So, it's value of 4. Then, similarly, we can write 4 by 1. Is it? So, it is also rational number. It is rational number. So, you can find what are the rational numbers and what are the irrational numbers. So, I will give the questions later. You try to solve some questions. Okay, thank you.